But by way of introduction, many of you will be aware that SCiMMA has built this messaging system we call Hopskotch, and we've built partnerships with LIGO and IceCube, the Supernova Early Warning Systems News, and we're just this week spinning up one with Howell Observatory for targeted opportunity from alert providers such as LIGO. And what we haven't had yet, which is one of the things that Andy and Curtis and Lindy will be showing, is a system that is simply usable by astronomers at all scales. And so this is a new interface that's being designed by Andy, Lindy, and Curtis, who are at the Las Cumbres Observatory and have a long track record of developing these sort of things for sort of follow-up coordination and so on. So I'll hand over to Andy, who will start, and then I think perhaps Andy's going to hand off to someone else after a little bit.
Yes, thank you. Indeed, I've been worried about this problem a long time. You know, how do we make the messaging system that astronomers use more useful? I've been waiting for somebody else to solve the problem since it hasn't happened and the clock is ticking. We're proposing a way to start the solution, but this will really take the community's input and help. But we want to have a proposal for what to do to start with, to make it easier to debate what to do. Okay, and I should add that we also added Joey Chatelain recently from Las Cumbres Observatory, an astronomer turned software engineer, in addition to Curtis and Lindy. Okay, so let's see. Well, my advanced slide, here we go. Okay, so, you know, here's what we kind of want to happen when we get a multi-messenger alert. Like we get, say, somewhat LIGO, Virgo, Kagra alert. We want the telescopes to automatically start observing once we get this alert. Already have figured out what our priority is on the telescope, so we don't have to argue about it, and figure out who gets access to the data. Have the data automatically be reduced and instantly be made available to anybody that has the priority to see them, or the access to see them. And then machines and humans make inferences based on the available data and repeat. So we want to cut humans out of the loop as much as possible because we're slow, and we want the things that can be made fast because of course it helps us on the science. Of course, it's more complicated than this. We have to find the targets and so on, observe some big area. We have a bunch of possible targets, and then we need to narrow down on the right one and then observe it scientifically. But you get the idea. Now, as for how it works today, I'm going to go through each step and point out where I think we can do better or where we're doing good. And then that is as set up to the demo that Curtis is going to give in a bit for possible ways to solve this problem. So LVK, or in the case of gravitational waves, but it could be the same kind of thing can apply to other things that aren't very well localized, like gamma ray bursts or neutrino detection can just be some region on the sky. Then they may issue a text-based, like a GCN circular or a machine-readable GCN notice, or they may issue an alert through a dedicated listener. So here's GraceDB that has the sky map of the region of interest. Okay, so we're doing okay on that, I think, especially with people having individual listeners built. Then you want to observe this region of the sky. And so that may be, you have a telescope with a large field of view and you just tile that region, or maybe you have a smaller field of view and you're observing galaxy by galaxy. And then you go and find a bunch of candidates. Maybe you find one candidate, maybe you find 20 candidates. Now, to solve this problem of coordination there, I'm involved in another group called the Treasure Map. You can find it at treasuremap.space or look at the paper by Sam Wyatt. And there, the idea is we provided a service where people can say what their plans are, and then also post their completed pointings. And you can change the underlying layer there to see what sky surveys are there. And it allows for better global coordination and follow-up. So I'd say we're doing decent there too, in terms of making new infrastructure. I guess the one problem there is it's not funded. So we're just doing this based on, you know, a lot of people putting in their volunteering their time to make such a thing. Okay. And then when it comes to reporting candidates, you know, let's say you've got some survey and you've observed this region. Now you have 20 possible transients in that region or something. Right now, the way people report them is largely text-based. They write some paragraphs about, you know, what the conditions were and so on. And then they maybe even make a table there. But as you can see, in looking this up on the ADS, this you know, table formatting can be screwed up, but also there's no standardization. So each group is just making their own table. So it makes this very hard to extract information from in some machine readable way. So for each one of these things coming ahead with I think pretty large problems, I've tried to name the problem, and we can argue over the names, but just so that we can refer back to what the problem is. So one of the problems is that there's no what I call the clearinghouse problem is there's no centralized place to report candidates or to look for them. There are some different places, so you can report things through the GCN notices or circulars. You can report things to the astronomers' telegrams. You can report things to the transient name server. But then, you know, the sort of natural authorities like LBK or NASA have different mandates than ground-based astronomers. And so, you know, in some cases, it's just not their job to support us as ground-based astronomers. And then there's a formatting problem. Like I mentioned, there's no standardization of how to report information in a machine readable way. Now, a bunch of groups have found a bunch of targets, and me as an astronomer, I want to go and observe them. But the problem has been that there can be what I call the information flow problem. There can be hundreds of messages about dozens of candidates going to different locations. Like I said, some in astronomers' telegrams, some in GCNs, transient name server, other places. And often they are unthreaded. So like if you look at just the GCNs, you know, you'll see in the list, maybe I only care about the gravitational wave event, but, you know, interspersed are all of these other kinds of things about other targets. And then there's a database problem, and that there's no centralized place to look, like a database that tells you the latest status of all viable candidates. So during some last runs, I was just starting a spreadsheet and sharing it with some colleagues about, okay, here's the 20 targets we think might be interesting. Let's just write to the spreadsheet what we know about each one, and then keep them updated as each new text-based message comes in. And then there's the problem of what I call the limited reporting function problem, and that is that the norm has been to report discoveries and types for a candidate. So let's say there's a new thing at these coordinates, or hey, I found this spectrum, and I think this is actually a type 2 supernova. And maybe you can share the spectrum on the transient name server. So in fact, that's what the TNS is built for, is for sharing the discovery and the follow-up, but not necessarily for sharing things like, hey, here's a new piece of photometry on this target. I didn't get a spectrum, but that new piece of photometry is useful information that could, you know, be put on a light curve. People sometimes send those in circulars, but again, without there being some kind of format standardization, you might not even know the units somebody's using, much less be able to extract it easily. And then there's things like context information, like galaxy information, historical observations, you know, UV sources in the field or X-ray sources in the field that you might want to report, that sometimes people report through these things. But again, there's no standard place to look or way to report these things. We could be reporting much more. One reason we don't is because we don't want to flood people with too many messages, which is, again, part of the problem. Okay, so next I want to trigger some follow-up observations. I've got a bunch of possible candidates, and I want to look at them with my telescope. So my own group, the for supernovae, the Global Supernova Project, but we have another group that does gravitational wave follow-up. We use a TOM, Target Observation Manager. So ours is the Supernova Exchange, where it basically organizes information about a single target at specific coordinates. So let's say, I tried to observe one of these things. It's a supernova. This system keeps track of my data and then allows me to trigger the follow-ups through the system. So I just say, push a button, and it tells my telescopes to go get more data, automatically reduces the data, starts plotting it on a graph. This is the older version. The newer version is built with the TOM toolkit. So that allows a bunch of people to trigger different facilities like SOAR and Gemini and Las Cumbres telescopes, for example. So I think, we're doing pretty good on that part of the problem because we built this TOM toolkit. There are other groups that have built similar systems. Sometimes they do call it a Marshall, or there's other names, but there's still a problem in that if one group has a TOM and my group has a TOM, there's not a good way for those two to talk to each other. So let's say we just want to share some data and not everything. That's tricky. In fact, we're facing that right now in one of my collaborations. So that's what I call the TOM communication problem. TOMs can't generally talk to each other. Okay, and then there's finding additional. So now, okay, I get some data from my telescopes through my TOM, but I want to trigger some other telescopes. Like I want to get some Keck observations. So, or whatever else. Even if I want to trigger Gemini, I need to go and figure out what's Gemini doing. Is the right grading or instrument on the telescope? Which observer at Keck is observing? Maybe I know them and I want to go and find something. So I have to go and look at the Keck website, go look at the Gemini website. As you can see, there's no standardization for what observers or instruments are available. Of course, there are other things like weather, meaning you may not be able to observe. So that's what I call the resource availability problem. There's no one place to look for available resources or telescope status. So as anybody that's tried to observe one of these kinds of targets, it's a big mad scramble when something happens. You now need to go and look up everything about places you can get observations and possibly call people on the phone even. And then once you have identified some resource to follow up, one of the problems is it can take you a while to do that. I've had, the summit of Mauna Kea on the phone saying, hey, I'm about to fill out this form to trigger some observations, but it's going to take me a half hour. So bear with me and don't start new observations, which is ridiculous in this day and age. And then you often have to fill out a graphical user interface. Now, Gemini is getting better at this. And now you can trigger through a TOM, which makes it much faster. But these things are still around in different places. And so that's what I would call the triggering problem. It can take you a while to go and request observations. And then there's something else I would call the conflict problem, which is that multiple groups may be triggering the same resource and have conflicting programs, or it may try to inefficiently trigger two different resources to do the same observation. So I might say, hey, I want to observe target one there that ZTF discovered, and somebody else is trying to observe that same target at a different facility, and yet nobody is observing target number 20. And if we had better coordination, of course, we would all be more efficient at following up gravitational waves events. And then after that, another slow step is the data retrieval and reduction. Often we have to go to an archive and download the data and reduce it. Then that's a slow step because it takes often a human to manually reduce data. So that's what I would call the slow reduction problem. But there's another problem that I would call the archive problem, and that is that archives generally don't talk to each other. They're all individual custom-made things. And so if somebody got data from somewhere and it's in an archive, unless I went and knew to go and look at that archive, I wouldn't know that, hey, somebody's already gotten a spectrum of this target until they go and report it. And then when we do report the results, often we send a text-based message back to our colleagues via some service that I talked about before, or we put something into the transient name server. The transient name server does have an API, so that's great. You can report things and get machine readable information there. It's a little limited in that the API is incomplete, and it's highly rate limited, so that even I just looking up targets on the TNS have been throttled, and so that makes it very hard to do in a systematic way, talking to your own Tom, for example. Okay, so and then not everything is reported to the TNS. Like I said, sometimes the first spectrum taken when establishing the type is reported there, but then not, say, subsequent spectra that could show something is changing or interesting. So I've mentioned most of these systems. So the GCN circulars, they have recently been overhauled, and it's been a nice effort by the NASA TAC group to do that. But it still has certain limitations. So, the circulars are text-based, and ground-based astronomers tend to use those. There are the machine-readable notices. The problem is there you can't interweave text and machine-readable parts very easily. And they're used by certain NASA facilities like SWIFT, but have not been widely adopted by ground-based astronomers. There's the TNS, which is a good way to get an official IAU name and classification, a very essential service. And so it works well for specific functions, but not for everything. Astronomers' telegrams just aren't machine readable at all. And there's a problem of there's a gatekeeper there and who likes to ban people. And so partly as a result of that, that's been largely abandoned by the transient community. Now, there are brokers also, but they are typically designed for, high alert volume from one specific group like ZTF or LSST. And you can filter a bunch of alerts, but there's not a good way right now for users to report back information of, oh, here's a target I got from a broker. I found out that it's this thing. And how do I tell everyone in the community what I've now found out about that thing? So in the SCiMMA group, we've made this system Hopskotch, which solves a few of the problems that I've mentioned. And one particular issue is, it uses Kafka as a messaging service, so it should be able to handle a bunch of alerts. But a big step forward is it's a pub sub model. You only subscribe to the information you want, publish and subscribe. And then if you get it jump started, it can carry existing astronomical images, messages like GCN circulars and notices. But we want to have things more machine readable, but to do that, we have to define a format. And that's been a stumbling block to this point. How do we get the community on board with, here's how you report an RA and a DEC and tell it that it's was found with this survey. We could ultimately support other types of messages like sending spectra, data points, but again, there we need to know the format. Another good thing about it is it's integrated with identity and access management. So, you just have your credentials and then it can know like what you're allowed to see and not see. In principle, in practice, this is a little cumbersome at the moment. But there is still this standards problem that we haven't solved. How do we all agree on how to make what we send machine readable? So that's the problem that we're really trying to solve today. Okay, and just a little bit more about this pub sub model. That's a real step forward here because you don't have to worry about every user receiving everything. So you can send many, many more messages, and each user, you don't have to worry that each user is getting too much stuff because they can say, here's exactly what I want to get. And possibly even send private messages, which many collaborations require. Okay, so I think what we need going forward now is a communication system that combines ease of use of free text and the utility of machine readability, hopefully in a way that you can interleave them both together, because astronomers have shown a very strong preference for writing just free text. So we don't want to take that away from people. We need standards for what to communicate, So like recognized key value pairs. Hey, I got this message. That's the RA and DEC. This is the magnitude. This is the spectrum of this target, and so on. We want something that has the capability of communicating a wide array of information. like discoveries, telescope pointing, I said paintings there, it should be pointings, photometry, spectroscopy, resourceability. So let's broaden that from what we have available today. It needs to be API driven so that it can be used and plugged into a TOM, because I have my observations on a TOM. I want to push a button and then just say, send this classification through this system without having to write out a bunch of free text if I don't want to. But it's also handy to be able to be used with a graphical user interface. So we want to provide both. The graphical user interface just sends something through the API is the idea, but you can roll your own GUI and the API will work for you. We want it built on Kafka, have an IAM system and interoperate with TOMs. And we want it to supplement and not necessarily replace existing infrastructure. You know, I don't think the TNS or the treasure map or anything else will go away. It should not go away, but we want to build things that work with these kinds of systems. And the same is true for GCNs, of course. Okay, so I think the path forward that I envision it anyway is that we wanted to make a proof of concept of how this could work, and then show it to the community. This is the first demo to the community, but we plan to go to different meetings and talk about it. Get community engagement and feedback for how they think it should work. This is just really like a possibility of how it could work. Maybe create working groups that would be open to whoever in the community has the energy to engage, which will say, this is how, you know, here's what you should call these different variables, or here's the kinds of things we want to communicate. And then refine and iterate the concept to have a minimum viable product by November 2022, because LIGO is turning back on for operations something like December 15th if all goes well, but it's possible that they'll have engineering kinds of announcements in November. So that's when we want to be ready. And Curtis will give a demo, but if you do have questions or comments or ideas, you can send them to hermes@lco.global, and that will go to all of us. Or if you want to volunteer to help out in any way, or even just you've got a lot of ideas about how messaging should be structured, or how it should work with your TOM, or something like that. Okay, I think there I'll turn it over to Curtis, but if there are any questions on what I just said, I'm happy to take them. All right, let's let Curtis take off.
Yeah, so thanks, Andy, for setting all that up. So this is the proof of concept system that we've been building over the last couple months to try and demo some of these different things. Now, some of the goals of this are a little different than we would do, you know, if we were planning to make a complete production system. So one of the things we want to do is we want to use this to really spur on discussion as much as possible. So, you know, none of this is set in stone. And so we really want to be able to make, make this as useful as possible. We've also tried to make it extremely flexible. And so I'll get back into that in just a little bit. So let me show you a little bit around of what's going on. So right now, this is listening to our Kafka stream to Hopskotch. And right now, we're only listening to two different topics in this particular one. We're listening to Hermes test, which we'll get back to in a minute, and we're listening to GCN circular. Now, I want to start by just looking at a couple of these, because you can see actually these are very recent ones. They've actually happened today. And just to, illustrate some of this again. So, here is one where it's like, the authors are in a specific format. There's some text, and then there's a table. Note here, coordinates are a single column here with parens around them. And then when you say compare that to one that's, maybe this one, maybe even just one message down. And I mean, these are real messages that have been sent. So it's not even like I cherry picked these. These are just the most recent events. You can see that they included a table, but again, they've now included totally different information. They've included both, times, and then they've included 5 SCiMMA limits here and things like that. So our goal here is we want to try to make this as follow a convention as much as possible. So what we've done is we've started laying out some of the most common workflows into their own pages. So for example, so you want to submit a new non-localized event. Now here, this could be, a LIGO event. This could be, this could be like a GRB or anything like that, anything that just doesn't have a localization. And so what we've done here is we've defined, some of the basic fields, titles, authors, a free text message, but we've also included this table here in the center. And this table here has a set of, of columns that we think pretty much every non-localized event will probably have. So discovery date, the instrument, a sky map, maybe a false alarm rate. In addition to that, we've also added a table over here on all the pages where you can add additional key value pairs. And these can be any values that you like. And so what we're trying to bridge here is we're trying to cover, the 90th percentile of all the users' cases with enough customization on the end to basically to customize everything else that you need. So let's just do a quick example. So let's go to, say, reports and photometry. Again, this is, as Andy said, this is something that people can do, but they don't typically do. And if they do, it's generally just in it's just in free text. And I just saw Aaron's question. Okay. Yeah, we can argue about nomenclature versus not, but that's fine. So let's see. So let's, we could say like photometry of, SN 2017 CBV, one of our favorites. I'm going to submit it to our Hermes test topic. Now, in this case, we've assumed that you have some kind of event that's some kind of super event ID. So I don't know, GWO 817, whatever, something like that. Let's see, the authors can be SCiMMA. And then let's say I want to upload some photometry. So I'm going to click here, and that's going to populate some things like that. Say, I want to say maybe a submitter is going to be me, whatever, that's fine. And then we got photometry. Please take a look. I don't know, something one day. And then I'm going to click submit. And if this goes well, aha, it now shows up in our list of messages. And so now this has come back and we can look at this. Now, in this case, we have a little bit more information in here compared to our old one. So, our message text is over here on the left, but our machine readable text is now over here in the right. And so this, because we have now put this in a machine readable format, we can extract that bit a little bit easier. Now, all this is really stored in JSON. So if you ever wanted to just pull this directly from the JSON, you're perfectly welcome to do so. This whole system is backed by an API with a relatively thin front end on it. And so anything I'm describing here can also be done programmatically as well. So, just to show one more, say we want to submit candidates for this particular one, and this one I'm going to use actual values. So this is a previous GCN that was in very much the same format that Andy showed earlier. And, there was a table of candidates in it, but the table was not really machine readable. And so this is, let's see, grab the authors real quick. And this is going to be S200-114F. All right. And let's see, what did the message say? I'll copy that in real quick. We observed localization. And so I'm going to grab this. I'm going to pull in my candidates. And then I'm going to say add one more row for like a submitter, just because. And let's see, let's grab Igor's name. All right. And so that's all good. and then I'm going to click submit. And oh, look at that. There's an error. And in fact, this is an error that I put in on purpose to show some of the power of having an API and having some of the conventions we have here. Because we've defined an RA as part of our validation script for this, we can actually produce messages. We can produce alerts when there's an issue inside your submission script. So, I mean, clearly 70 is not a valid RA. So I'm going to go back and I'm going to fix this. And I'm going to change this to 07. And then I'm going to do that. And then I'm going to try to submit this again. And hopefully it's going to go through this time. And voila, there it does. Now, again, here's the entire message of the text read or of the human readable text on the left side. But now you have a full JSON table on the right-hand side, such that you can extract any of this programmatically. Now, on top of that, we've also submitted to a specific topic. And so not everybody who is listening to Kafka is going to be, or to Hopskotch is going to be getting this. We've actually put it on this Hermes test, and there it goes. And so these are the two messages that I've just sent. And so anybody else listening to this stream, I haven't gone and just polluted their stream by throwing junk messages into their stream. And so this fixes one of the problems that Andy was talking about in some detail, that we're not going to overwhelm people with messages. One of the complaints I've heard about, say, some of the TNS astronauts, for example, is that some people just report candidates from them. And so they get 100 of these things, and they're just every supernova that's ever been discovered. And there's some use to that, but then you also want to be able to filter that out by, say, actionable things, and so that you don't get really this alert fatigue and get overwhelmed by the number of messages. And so this, I think, is where the different topics are very, very powerful. So for the system so far, we've got something, we've got a couple things for, reporting the observatory availability, spectra, photometry, a search pointings page, which we hope again to integrate, and then connect that over to treasure map. Non-detections, a lot of times non-detections can be very important, and those are exceptionally hard to report traditionally, candidates or, like some kind of super event. And so I think that's where I'm going to stop. We're still in the process of getting the user authentication to work. We've spent quite a bit of time with the security policy committee talking about authentication. But once we have that in place, we want to demo this, say, kind of about AAS, and actually have people start playing with it, poking at it, things like that. So I think with that, I'll stop and ask for comments and questions.
I do want to also point out, while people are thinking of questions, that we would like to have it so that as you write the message, you can refer back to something in a machine readable table that you have uploaded. We are still thinking about the best way to do that. So that's one of the things we would like to have feedback from the community. For example, you might put it in brackets or some other kind of thing to let people know, hey, I'm referring to this thing that's in a machine readable format. And then another thing, I don't know if you mentioned, Curtis, because I was in the chat some of the time there. Did you show that how this is a JSON? And
Yeah, I'll do that again just to pop that up. But yeah, so like all of this information is in JSON. And so, you can then extract this data with, say, a TOM system automatically that's automatically listening to this and parse it into some kind of usable format. And, if your parser finds something you like, have it send you an email. Really kind of the sky is the limit on what you can do once you have the data.
All right, great. So if people have questions, happy to hear it.
Hi, Curtis. Great demo. Hey, so quick question. So the CSV you just imported, that's prepared manually beforehand, right? So the bottleneck is still it's not from the real, well, it's from a real circular, but it's still, you manually made it.
So in this particular case, yeah, for the demo, I manually made it, but there's no reason that you couldn't have, your TOM make these automatically. Or Yeah, I mean, again, you could, if you just are using boilerplate text, there's no reason your Tom couldn't submit the whole message for you. So it's just, yes, in this particular case, I did do it just because you didn't want to watch me type 8 different lines of of events in a demo.
Got it. Thanks.
All right, Gotham next.
So I guess this is all great. I guess what I'm struck by is how much this would be better if this was integrated into TNS directly. And this was the TNS front end for submissions in the first place. And I figured I'd A, sound you out about your thoughts for that, and B, have you folks given any thought to making this also a full replacement for something like supernova.space now that that's no longer being maintained?
So my thought on the first part is I agree that, but we want to have a proof of concept before we really started approaching people so they can see what we're talking about. I'm going to a gravitational wave workshop in Israel coming up in a month or so. So my plan is to talk to everybody there and say, hey, can we just make this so that the user doesn't even have to say, one of the problems we have right now is I have to report, a discovery thing to TNS, something else to Treasure Map, something else to GCN, maybe something else even to ATELS. And I want to just be able to do it once and have all these other systems listen to a common stream. So I would love it if TNS is able to make that happen. So it shouldn't be that hard once everybody's agreed on a format. In fact, we were happy to work with them on a format. Same thing with Treasure Map. In the Treasure Map team, we've talked about, it's a possibility in the future somebody just reports their pointings to this kind of system and Treasure Map listens to that. So you don't have to go and separately report at the Treasure Map. But these things are open to discussion.
Yeah, and I mean, one of the hopes is really to start getting these different pieces together. I would love to see, Antares hooked up to one end of it, so that goes back through. And so I hope that they're all connected in the long run. This is part of that clearinghouse problem that Andy was talking about.
Yeah, and this is why I brought up the supernova.space replacement, essentially, because this is really, you've got the same thing that James Gearchon had for inputting data programmatically and accessing data programmatically. So you could make this full light curves, not just discovery events and candidates.
Yeah, we have deliberately stopped. I think that's a great suggestion. And you could imagine just having a tag that says, hey, this is published data. It's in my paper, blah, blah, blah. But then, of course, there's another problem with who's going to make the database to make it easy to sort and find all of that stuff. Right now, we're leaving that somewhat to the individual users who have TOMs and so on. So it does make you think of a bunch of interesting new possibilities. We do have to stop and say we're making a tractable, manageable problem at some point. But I agree that once we have done that, it introduces totally new software that we also need, or new databases and other things.
This is great, guys. Just let us know how we can help get this out the door then.
Yeah, I will be calling all of you up and saying, would you like to join some working group that helps figure out how this actually works in practice? All right, Derek.
Yeah. So I guess my question, you raised a couple of issues with the current system in your talk, Andy, and I just wondered, so is HERMES also helping out with the Tom-to-Tom communication? Is that part of the solution?
So yeah, I'll give the example of what the problem that we had is that in my group, the Global Supernova Project, we have a supernova exchange. And then Ryan Foley's group has a different TOM system built with different technology. And we're trying to figure out, okay, we want to share the information on the same supernova that we're both working on together on this Keck infrared program. How do we do that? So we could design something that says, I send my data to their system. They send their data to our system. But now if I want to do that with other groups, I've got a many-to-many problem, where I have to make a one-off interface to everybody's TOM, and you're back to the same standardization problem. So the way I imagine, as I told them, and that's one of the things that jump-started this whole idea here, is if I just publish to one stream on Hopskotch, then as long as we agree on the format, we can both publish to that same stream and both read and write from it. and then have our toms interpret it.
Right.
So
you're publishing and you're subscribed.
That's the whole idea.
Yeah, multi-sub. Yeah, okay.
And especially given that these topics can be private between different groups, then you don't have to worry about that data is just floating out into the ether. If there's nice connections between that as well.
Got it. Thanks.
And ultimately, I would like to see, and we mentioned this a couple times, just observatories publishing, hey, here's our schedule coming up, here's the instruments on the telescopes, and so on, to some common stream, and then making some interface that is a thing that you can just go and look and see, hey, tonight I could observe on the following telescopes. That will make TOM systems much more usable as well.
Got it. Thanks.
I think Aaron's up next. Go ahead, Aaron.
Hey, thanks, guys. This is really cool. You guys have done a lot of work that I think everyone else wanted, but no one else wanted to do. So thanks. That's fantastic. My first question is, can I use it now? I'd like to use it now. And then the second point is that this question about definitions. I know it sounds pedantic in the chat, but I think problems that we've had with systems like this before have often run into definitions, have often run into people understanding what the use case for different streams is or are. And so I think it's just important to really focus on that so that the tool gets the most utility. But yeah, I mean, the main question is, can I use it now and how? This demo is entirely for the purpose of saying, okay, how do we really do this? In the sense of, this code is usable, but it's not not all the pieces are in place, because like the authentication and access management is a big problem that we are working to solve. Right now the issue is, I go to my TOM and I have a login for my TOM, but as envisioned with Hopskotch, it's more of a LIGO-like system where you just go with your Gmail account or whatever, and it knows all of your permissions. So making those two things work together is the current problem we're working on, just slightly less urgent than the demo ability. Then, there's multiple ways to make standards, and one of the ways is to just make something functional, and then if everybody uses it, it de facto becomes a standard, as we did with Treasure Map, right? Yeah. The other way, of course, is the VO event kind of thing, where you debate every possible case and figuring it all ahead of time before you actually make the implementation. We don't want to go too far in that direction, but I also don't want it to go too far in the first direction, because I want community buy-in, because I don't want this to be something that people don't feel ownership over. I want the whole community. I want people that do, comets and whatever to be able to use such a system. I want it to be useful for all of astronomy. So I don't want to just dictate based on limited knowledge. And besides, different people have different instruments, different, as you were just saying with the localization issue, maybe you think about it in one way with Swift or whatever, and somebody else, an optical astronomer, thinks about it in a different way. In terms of this localization thing, I'll just tell you the reason why we made a thing like that. It's because in a TOM system, we have the convention that an event is associated with particular coordinates. And so that's usually optical astronomy biased, and it's saying, hey, this supernova is at this coordinates. Once we went to gravitational wave events, we realized, that breaks the whole TOM model. So we need something where the coordinates are not well known. And we started with the use case of the gravitational wave event. So we started calling it a super event. Again, based on your feedback, that's not generic enough. So we started calling it non-localized events, because that could be used for, say, neutrinos, or it could be used for, gamma ray bursts or something like that. I agree that there's a weird case in the middle where maybe something to a few arc seconds, but you don't really know it really precisely. I didn't want to put a hard cut on what counts into what area, because it's very different depending on the technology. But so you're welcome to join any kind of working group where we define what these boundaries are. But the general idea is that if it's something that will require follow-up to precisely determine what that physical thing is, then that's what counts as what we call a non-localized event. The terminology doesn't really matter to us. It's just, you know, is it something where I've got some observations at one wavelength, I probably need them at another wavelength, and that will make me have it be precise enough to get a spectrum.
Yeah. No, but as you said, working toward. I'm sorry.
You're breaking up for me. Maybe you can type it if it's too.
Okay.
Yeah, and Derek says the former VO event effort allowed themselves to get a little too hung up on the edge cases. Yeah, I mean, I agree that you can spend an infinite amount of time talking about every possibility. And so our way of working, my way of working at least, and the way we've adopted at LCO is just try something. Don't design yourself into a corner, but solve the most important problem first, and then go on and add to the solution. Sometimes you have to do some refactoring, but that's okay. And Aaron says, yeah, there should be some clearly defined boundary, whatever it is. Happy for you to propose a solution. Because that's something where I have not been able to think about exactly the way it should go, but I mean, maybe I just don't know enough. And I think each person's, we've deliberately left it vague because, you know, somebody at one wavelength regime would say one thing and somebody else would say another. Somebody else brought up radio and yeah, fast radio bursts might be another kind of case of something that's not localized.
Just to say one more thing about edge cases. That's one of the reasons we've adopted this particular model in the back end, is that we're not really dependent too closely on the exact message format. We've really tried to be as general as we can when we store this. We store basically just raw JSON in our database, but we want that JSON to be parsable. And so, you know, that does mean setting some kind of conventions. And so we're really trying to set conventions without dictating things from on high, basically.
And yeah, Chad.
Well, I think Curtis actually answered part of my question. By the way, Andy, Curtis, all this was great. Thank you. I think the point you raised about sort of straddling between the case of VO event and the Wild West is really important. And I think one of the ways that you can help the community embrace whatever your plan is, let them know that you will be able to remain flexible and to adapt. I mean, to sort of have a clear migration path that allows some refactoring, you know, as more and more people weigh in. Because inevitably what will happen is you'll get some small amount of the community in the beginning, and then as more people come on, you'll find that the design requirements will change relative to what they were in the beginning. So
yeah, I would say all of our software at LCO is on the second or third or fourth generation, because we built something that worked for a while. After we used it, we saw what it needs, and then we redid it. But that model has been quite efficient. So the reason, by the way, this is named HERMES is it does have an official acronym, which I said in the thing, but it's also because we made the Mars broker because everybody else in the community, the brokers weren't ready when CTF was ready. And so we made one called Making Alerts Really Simple. It's called Mars, just for that. And we were able to rush something out that just solved that problem, but then wasn't designed to be built on from there, because we knew there were going to be more complex brokers. And so we just decided, okay, let's go with the messenger god for this one. But it also has an acronym that involves Hopskotch. Okay, so but anyway, yeah, I do like that model, I think. But the tricky part is getting people who have strong opinions or not so strong opinions to get engaged and use it, and not see it as oh, we don't want there to be one person's system and then another person's system and so on. We want the whole community to really be working on this. And again, this is very slightly funded from SCiMMA, but it's been a lot of LCO resources just put into this as well. So it's not something that's incredibly well funded. And so
we for a little while, we need some volunteer effort, but it is the thing that we keep getting feedback on in different proposals. You need more community engagement. And we've, until we've got a working system, it's harder to have the community engagement. But once you've got something to argue about, it's easier for the community to get engaged.
Patrick, my hand's back up.
Yeah, can you hear me okay? Maybe not. Can you hear me?
You're a little robotic, but we can make out the words. Yeah.
Okay, hopefully. I was just going to make a comment. I think it's really great. And I guess let me just encourage that in SCiMMA, we found a couple of projects where we've been able to develop some quick collaboration using small teams, using sprints and product owners and very simple approaches to code development that really make it easy to engage a broader team. So we should basically try to figure out how to get a meeting that is not just SCiMMA, but is broader, and get them chatting about, what's the next big thing to do, what's the best, what's the next step, how should we prioritize what to do next. We've got some skill, some experience with how to make that work well, and drawing on that team experience may be useful to the rest of the community if people want to get involved.
Yeah, I completely agree that forming small working groups and solving particular problems are absolutely the way forward. And I've talked to people in other areas of the astronomical community that are not just MMA people, and they're excited about using it as well. And of course, as we know, Rachel Street did a huge amount of work on getting the Tom Toolkit to where it is today. And she's not an MMA astronomer. So I really want to make use of as many different groups that it really works when we have a common problem. The Tom Toolkit was an example of where we had a common problem. Rachel and I had a common problem. We were each reinventing the wheel. We said, well, why don't we just work together to solve our particular problem? And then it's become such a useful platform. We see buy-in from other elements of the community who have contributed modules and other things. And I should say that we hope that this will be something that can be plugged into a Tom, but there can also just be a website that you can go to without having a Tom to be able to see these kinds of messages and send them in some default way. And then, but if you want to make something more complicated, you can roll your own as well.
Yeah, really want to lower the barrier to entry as much as we can. And some of that is some of the things we're thinking about to try on improvements for the UI. They involve things like, trying to be able to access that JSON data, that machine readable data inside the text message, for example, to be able to, make writing the messages faster, collaborative tools to help making the messages write faster, those type of improvements.
I don't know if I have the last hand. We'll have to end here in a second. I guess with my LIGO hat on, first of all, Andy, I love this idea of getting more people to report essentially instrument state and intention, which I think is really, we talked about this early in SCiMMA too. I think this is key. And I confess, I don't remember exactly what all LIGO makes available these days in terms of those things, but I've always thought we could do a better job with my LIGO hat on with doing some of that stuff sort of in real time. This is just making it easier for people. And anyway, I would love to personally help out or volunteer some of my students to help out with that side of things, if assuming LIGO is ultimately okay with releasing some of that info. That could be super helpful. So it'd be fun to plug in that.
Yeah, great. And I do think one of the beauties of this approach that we've come up with is that the problems with, I don't want to just keep ragging on the VO event. Like that whole system, because they had a noble idea and I think they were ahead of their time, and it's just very hard to solve the problem for everybody in the abstract. But with this approach, I think we, meaning like me and Curtis and whoever else is directly working on some of the hardware aspects, don't need, or the software aspects, don't need to solve all the problems. The people in LIGO can tell us, oh, just here's the fields we need. And then we provide this other part of the infrastructure. And that, so we're, separating the really, really tricky part of let's solve all the problems. All we provide is we just say, it's probably going to be JSON, and And then here, I think the other thing is when you have the use cases in these little panels here, I'm not looking at a blank screen and just trying to compose a message that will say whatever or solving the general problem. I'm solving this one problem of how do I report a piece of photometry? How do I report an event? How do I report the LIGO status? And then, 90% of the messages reporting the same kind of thing are written the same way. And so we might as well just make a de facto standard and then have iterations from there.
Yep, I agree. That sounds great. All right, well, we're at the hour. If there's one last burning question or comment, we could field it. Otherwise, let's thank Andy and Curtis and others at LCO and beyond for this again. Thank you.
I guess, Chad, if I could, I'm going to throw one last comment, which is let's follow up on this, perhaps with some email exchanges and messages with those who are online to figure out how to actually get those small working groups like Andy has been advocating and really, take a step forward. I think it'd be really great.
And I would also say that we are happy to demo this at different meetings. We'll be at the AAS and hopefully talking to different people about it there. There's a couple of more meetings I know coming up. So if you know of or have a meeting, feel free to recruit one of us, because the big push now is going to be getting community awareness and engagement. And it's only going to work if people in the community say, this is a good idea, let me help, and let's figure out the next path forward. I don't propose this as us solving the problems for the community. This is just like, let's get the conversation jump started.
Yeah, that sounds great. And like I said, sign me up. I think I've got some new students who could maybe help with some LIGO stuff.
Excellent. Well, thanks everybody for coming.
Yeah, thank you. Bye all.